In this lesson, you will learn how to identify key features of functions. This is going to be over domain and range. Domain is going to be your input or your x values. And your range is going to be your output or your y values of the functions. You may choose to write your domain and range as set notation or interval notation. You're probably more familiar with set notation from previous classes, but as you move into higher level classes, many times they use interval notations. It's always good to know both, and especially be able to go from one to the other, but interval notation becomes more common in the higher level maths. So for number 1, we have an exponential function. Here for our graph, any x value can be used to make this function. So here we have along this graph, I can plug in any value here in the negatives, and it continues to go out towards negative infinity. I could choose any positive y value, and again, it goes out towards positive infinity. So we could say for our domain, it's all real numbers. So we could use the symbol for that. It's a kind of like the paragraph symbol where you do the double line, but make it an R instead of a P for paragraph. Here we do R for all real numbers. In interval notation, we would just say that that graph goes from negative infinity to positive infinity. Be sure that you're labeling your domain, whether you're using all real numbers or the negative infinity to positive infinity. Now for our range. So our range is our y values. We don't have any part of the graph down here in the negatives. There's also a section here of the graph that you cannot get. If you plugged in any number, like we discussed, any real number would work in this function. You would not be able to get out these types of numbers here along this y portion of the graph. So our domain only starts, our only range only starts here, one place below where the y-intercept is. That's at 3. So our range is the set of all y's such that, and this is just the format for set notation, the set of all y's such that your y is greater than or equal to, not equal to. For exponentials, they get very, very close to that c value, but don't touch it. So greater than, but not equal to, that 3. So this graph turned up, and all of those numbers greater than here would be included. Or for interval notation, you could just say from 3 to infinity, you would use a parentheses around the 3. Since it never touches, it gets very close to that 3, you'd use a parentheses. If it actually touches 3 and we want to include it, we would use a bracket, and we'll see an example like that. Infinity, you always use parentheses in interval notation around infinity or negative infinity. Let's look at example 2. Here we have a quadratic function. Again, for quadratics, any x value can be used to make this function work. So we could choose any number along the positive x-axis. As you see, all of those values continue on forever. We could choose any number on the negative part of the x-axis. Again, they continue on and on. So our domain, once again, can be all real numbers for this quadratic, or we could say from negative infinity to infinity. Either one of those would be acceptable. The infinity symbol was struggling there. There you go. So for our range, notice for our range value, we do have y values up here on the positive portion of the y-axis. We could input any x value and maybe get out some of these positive y values. We could even get down here some of these portions of this negative y values, but notice at our y, the lowest number it should reach is -5. If it lines up with our vertex of our function, this is at 2, -5 for our vertex, which is what we see. Here, -5 is the lowest that graph will reach. So our range is the set of all y's such that y, since the graph turns up and has an open U shape, again, we would say greater than or equal to. There is an actual point touching that -5, so greater than or equal to -5. If this graph was turned upside down facing the other direction, then that would need to say less than, because those y values would be less than this -5. Ours is greater than because all these y numbers are above, greater than that -5. You could also say -5 to infinity for your interval notation. Because there's a point at that vertex, we would include that -5, so this is where we'll use a bracket. And once again, an infinity symbol just has our parentheses. Let's look at another one here. Here we have a square root function. So our domain would not actually be all real numbers. If you have ever set the radicand greater than or equal to 0 and solve for the domain, you should know that that is the case here for this square root function. We can see with our graph the x values are here on the positive side of the x-axis, but we never reach over here to the to the x-axis that is negative. And that is because, like we see here in our picture of our graph, our x values are only going the set of all x's such that x is greater than and equal to, there's a point there, greater than or equal to 0. So to write that as interval notation, we would say from 0 to, we do go all the way out to infinity. So from 0 to infinity, we do want to include the 0, so put a bracket and parentheses around our infinity. For our range, we can look along our y-axis. We're not going to have any output values down here in the negative region of the y-axis. Even these first few numbers on the y-axis, our first y value that we get as an output is at +4, which again we see that in our function. So we can say our range is the set of all y's such that those y values turned up and are greater than the 4. If this was turned down, making kind of like a upside down square root function, just going the other direction, it would have been less than or equal to, but these numbers are greater than or equal to, and we were at the 4 on the y-axis. In our interval notation, we can say our graph goes from 4 to infinity, using a bracket around the 4, because again, there is a point there at the 4 to include it, and then a parentheses around our infinity. So just to help you with some interval notation practice, interval notation is the representation of an inequality using square brackets like these and parentheses like these to show whether or not things are included or just greater than or maybe even equal to that value. So if we have, and these x's are typos, not supposed to be there. If we have the set of all x's such that our x's go from 3 to 8, we can rewrite that using interval notation. So 3, 8, because it says it's equal to that 3, we include it. It's equal to that 8, we include that. So it is possible to have brackets at both ends. Here we go from -2 to 4, so -2, 4. Because we are not including them, we would put them in parentheses. There's no equal to, so that's where parentheses come in. Here we go from 0 to 3. Here the 0 is not included, so use a parentheses, but the 3 is, so use that bracket around the 3. And then finally, x being greater than or equal to the 9. So here we have 9, and it's going to want every number greater than 9, so that's going to go all the way out to infinity. Because it is saying equals to, we want to put a bracket on that 9 and a parentheses on the 8. Let's do one more and say maybe the set of all x's such that x is less than or equal to, I don't know, -9. So here, because it is less than or equal to, We are going to put negative infinity first because it's actually smaller than negative 9. So negative infinity, then negative 9. All of these have gone in least to greatest order. Negative infinity, you always put parentheses around it. Because there's an equals to, we would put a bracket around that negative 9.